LangGraph is the best AI agent framework for real business use cases. And in this video, I'm going to show you the core concepts of LangGraph. And I will make a little code example at the end using LangGraph.js because there's already a lot of Python tutorials out there and I gotta look out for my JavaScript homies. But even if you're not interested in the JavaScript part, the core concepts are all the same and you're still gonna get a lot of value in this video. Let's talk about the most important LangGraph concept. So there's the state, the node, and an edge. These are the three building blocks for the graph. And first you have the state, and the state holds all the data the graph has access to, and that could be anything: strings, numbers, objects, AI, messages, chat histories, or database queries. You're totally free to use whatever you want in a predefined structure. And then you have the nodes that are just code that is executed and it has access to the state. And at the end, it can modify the state as well. And you have edges that connect each node. So they decide which node is run first, which node is run next. But you can also have conditional edges that use the state to determine which node should be run next. So you could think of something like this. So we run this node, then we run the next one. And then based on how the state has updated, we can decide, okay, first, do we want to run this node or this node? And then if we're here, we can also go back to another node. And then finally, if we're happy with the result, we can go to the end and the graph is finished. So now that you understand the core concepts behind LangGraph, let's jump into the editor and build out a little example. So to get started, I initialized a new project and I installed LangChain, LangGraph, and LangChain core. First, we have to define our state, and the state's gonna have the type of annotation.root. In the state, we can define the data that we want to use. For example, let's use something like message, and message is gonna be type of annotation string. So this is the basics to define our state. Let's define something else, past messages, and that would be a string array. And we could even define our own types here, but let's keep it simple for now. Next thing to know is that inside the annotation, you can define two things. One is the default. That would be a function that returns the default values. So we could have this one be an empty array, for example. And the next thing is a reducer function. That's a function that takes in the current value of this part of the state and the update value. And then it needs to return something. So for example, if we want the new value to be appended to the current value, we could do something like current value concat updated value. And if we don't define these two functions, the default behavior is to overwrite it. So every time we would update the past messages with an array, it would just overwrite it. But with the reducer function, it gives us the possibility to define our personalized function. Next, let's create our graph, and then I can give you a couple of examples how this reducer function and the state update works. Let's define our new state graph as workflow is new state graph, and it takes in our state. Now that we have defined our state graph, let's add our first node. And we have to give it a key. Let's just say node 1. And it's going to take in an action. And the action is going to be a function. And this function is going to take in the state. And then it has to return our updates to the state. So in our first node, let's initialize the state. Message is hello. And past messages is hey. Now let's add another node. Let's call it node 2. In the second node, we will have access to the updated state. And then we also have to return something. If we don't want to update the state, we can just leave it empty, but let's update the thing. So our new message is, how are you? And then our past messages could be the state dot message, so the old message. And now, because we have defined the reducer function up here, instead of overwriting the past messages, it will just concatenate these two arrays. So now it would be hey and then hello. So to show you and to test it, we now have to add our edges. First, we need an edge from start to node 1. And then let's add another edge from node 1 to node 2. And finally, add the edge from node 2 to end. Now our graph is ready. So let's create it. Graph equals workflow.compile. And now we can call graph invoke and log out our result. Let's run it and let's see what the output is. And after we've invoked the graph, this result will be the final state. Let's just run it. And now we can see our first message of hello was overwritten here to how are you, and the messages were concatenated. So if we would remove this part and run it again, we can see also this hey was overwritten and we just get this one erased. Let's undo it. Now add a third node and add a conditional edge between the two nodes. So first add the new node. Let's just call it node 3. Let's make it the following. So in each node we put the current message in the past messages and set the current message to hello from the node we're currently on. And now let's add our conditional edge, and this will take in another function which has access to the state, and it has to return a string that is the key of one of the nodes. What we could do, for example, is we could say if state past messages length equals 1, we go to 3, and else we go to node 2, and then add another edge from node 3 to node 2. Okay, and then we have to get rid of this edge from node 1 to node 2. So we start at node 1, then we have our conditional edge, and then we either go to node 2 or to node 3. And if we go to node 3, we go back to node 2, and if we go to node 2, we go to the end. Let's try that out. As we can see, we went to node 1, then we went to node 3, and then we went to node 2. Let's just change that to unequal, run it again, and now we see we go to node 1, then we go directly to node 2, and then the thing ends. One more cool thing that I want to show you real quick is that we can actually get an image representation of our graph. I'm going to use bun here, but if you're in a node environment, you would use fs to write a blob to the file system. Let's just call this my graph png, and then we can use the graph get graph draw mermaid png, and this will give us back a blob. Then we can write it to the file system and we can get a visual representation of our graph, which could be helpful to see if you forgot something. As we can see here, for some reason there's a problem with generating the conditional edges, so it shows conditional edge to the end, which is not true, but we can see, so we have our node 1, we can go to node 3 or node 2, and then node 3 goes to node 2, and this one goes to an end. That's all that you really need to know about LangGraph to start building graphs, and we haven't even used AI yet, but that's where all the magic starts to happen if we have AI inside these nodes manipulating the states, and our conditional edges can potentially use AI to decide what should be the next step. And in the next video, I will build a full graph that solves an actual business use case. If you're interested in seeing that, make sure to subscribe to the channel. See you in the next video. Thank you for watching.